Good morning to our lecturer and classmates. Welcome to our engineering sharing session. Our group will talk about an important engineering topic: how electromagnetic wave uses, especially 5G networks, affect sustainable development. As engineers, we need to check the environmental and social influence of our technology. Today, I have 4 team members to share different views. One expert on electromagnetic theory, one public health researcher, one environmental scientist, and one sustainable design engineering. Okay, first, let's start with the basic teach. Could our first member explain how 5G uses electromagnetic waves and what set it apart from 4G and earlier model network?
Thank you, moderator. To understand 5G, we must look at the electromagnetic spectrum. While older networks like 4G operate primarily on lower frequencies below 3 GHz, 5G introduces the use of millimeter waves, ranging from 24 GHz up to 100 GHz. According to recent literature studies by Lieton, these higher frequencies offer massive bandwidths, allowing data to be transmitted at speeds up to 100 times faster than 4G. However, high-frequency EM waves have shortened wavelengths, meaning they suffer from high propagation loss and cannot easily penetrate solid obstacles like buildings. To solve this, 5G engineering adopts massive MIMO and beamforming technology. Instead of broadcasting EM waves blindly in all directions, beamforming acts like a directional flashlight, targeting signals directly to the user's device. This directional transmission significantly reduces wasted radiation and optimizes spectrum efficiency. Furthermore, technical reports from the ITUT show that 5G networks utilize up to 85% less energy per bit transmitted compared to 4G, making the current data transmission process inherently more efficient.
Thank you, Panel. Building on this technical efficiency, we must realize that 5G acts as a growing enabler across multiple societal sectors. In our lecture review of sustainable engineering applications, 5G is a massive driver for global carbon reduction. Take precision agriculture as a primary example by using 5G's massive machine type communication thousands of real-time IoT sensors can monitor soil moisture, temperature, and crop healthy simultaneously. Studies indicate this can reduce water wastage in irrigation by 30% and optimize chemical particle application. Furthermore, 5G's ultra-low latency powers advanced smart grids and telemedicine. Remote health care reduces need for patient travel, which directly lowers transportation-related greenhouse gas emissions. Therefore, from a system-wide perspective, the smart implementation of these EM waves actively supports environmental sustainability. And it is clearly that 5G brings unparalleled technical and operational benefits. However, um, engineering solution is never without its complexities. The public has raised survey concerns regarding the potential hazards of SMEM radiation on human health and ecosystem safety. Is 5G truly safe? Let's hear, let's hear from our healthy and environment partners.
Thank you, moderator. Public anxiety regarding 5G radiation usually stems from a misunderstanding of physics. We must emphasize that 5G electromagnetic waves fall strictly under the category of non-ionizing radiation. According to the World Health Organization and the ICNIRP guidelines, non-ionizing radiation does not possess enough quantum energy to break chemical bonds or cause direct DNA damage. Unlike ionizing radiation such as X-rays, the only scientifically proven biological effect of wave frequency is tissue heating. However, because these wavelengths are so short, the heating effect is restricted almost entirely to the surface of the skin, and the temperature risk is negligible, well below international safety threshold. As long as the network infrastructure complies with existing international standards, current medical literature shows no credible evidence linking 5G AM exposure to adverse health effects. Well, I agree with the panel too that the direct radiation's risk to human health are well within the threshold. We must critically evaluate the wider ecological and environmental impact. As engineers, we cannot ignore the massive problem of electronic waste. The rapid transition to 5G has accelerated the obsolescence of older hardware. According to the European Parliament research study, billions of older mobile devices and telecom hardware are discarded globally, leading to toxic chemical leakage in landfills and the heavy extraction of rare earths and mineral for new infrastructure. Additionally, some preliminary ecological studies suggest that high-density small cell towers could potentially cause equalized dielectric heating in small insects and birds that nest near the antennas. Therefore, while the radiation may be safe for humans, the physical footprint and the material life cycle of technology pose a severe threat to circular sustainability.
To address these complex engineering problems, we propose three concrete solutions. First, we must implement green infrastructure. Telecommunication operators should magnetize the integration of solar microgrids and engineer storage at base stations. Furthermore, we must deploy AI-driven power management, allowing 5G base stations to automatically enter a deep sleep mode during low-traffic midnight hours, reducing unnecessary energy grids drain by up to 50%. Second, we must solve the e-waste issue through a circular economy design. Regulators must enforce extended producing responsibility, ensuring that 5G hardware and base station components use model designs. This makes parts easily repairable, upgradable, and recyclable without scraping the entire unit. Finally, we recommended the establishing RF-EMF buffer zones around highly sensitive ecological areas, wildlife rivers, and elementary schools to minimize the cumulative exposure to vulnerable biodiversity, ensuring technology consists the harmony with nature. Thank you, everyone. Inclusion our group's consensus is that the application of economical waves in 5G network is fundamentally safe and highly beneficial for global sustainability, provided that the engineer communication takes active responsibility for its infrastructure life cycle and the energy sources.